Thumbs up if you love maths, thumbs down if you don't, right? You can put it in the chat box, or you can just give your reaction on the screen. All right. I see that a lot of people have put their thumbs up, right? And I'm asking the question because this is an important question to keep in mind, especially when assessing children in regards to their mathematics skills. I see one thumbs down, right? And so keep that in mind. Keep the emotion that you've shared through the thumbs up or the thumbs down. Keep that in mind as we go through our lesson today. Just to activate your prior knowledge about what we will be talking about, and that is the specific learning disorder with impairment in mathematics. By now, you are aware that the mathematic disorder, which is also referred to as dyscalculia, is a severe disability in learning and using mathematics. As with dyslexia, a term that is applied to severe reading disability. And this also impacts on a learner's ability to make use of their quantitative skills. And so keep that in mind as we continue to have a conversation about assessment of mathematics. It is important to also keep in mind that there are indicators or that shows up, or lack of prerequisite skills, problematic skills in mathematic disorder that is present due to poorly achieved skills. And those skills are the four categories, which is the linguistic skills, the perceptual skills, as well as the mathematical skills and attention skills. But we need to keep in mind and remember, however, that each student is unique. And not all learners who have a mathematic problem will exhibit the same characteristics. Research has shown that for some learners, difficulties with mathematics has a relationship that begins at early childhood development. The ability to count, match, sort, and compare, and understand one-to-one correspondence hinges on a child's experiences in manipulating objects. Hence, research has uncovered the importance of allowing children to crawl around. Research has also shown that a child with a short attention span, unsustainable perceptual skills, or inadequate motor development may not have had sufficient or appropriate experiences with activities of manipulation that pave the way for understanding space, forms, order, time, distance, and so forth. And so we keep those things in mind. But most importantly, I do want to emphasize that each student is unique. Therefore, when we look at the four groups of skills that are poorly achieved in learners who shows a disorder or a lack of skills in mathematics, we keep in mind that not all of them will exhibit these four skills. Some might exhibit one or two, but it affects how they approach mathematics. Now, other characteristics of learners with basic underlying mathematic difficulties also includes disturbances of spatial relationships. Now, normally, young learners or young individuals learn by playing, right? They play with objects such as pots and pans, with boxes that fit into each other, and objects that can be put into containers. Now, these play activities, according to research, help develop a sense of space, sequence, and order. However, parents of children with mathematics disabilities often report that their children did not enjoy or play with blocks or puzzles or models or construction type of toys as preschoolers. Learners with mathematics difficulties may therefore have missed these essential number learning experiences that should have happened quite early in their development. And then we have the second bullet point, and that is the disturbances of visual motor and visual perception abilities. Now, learners with mathematics disabilities also sometimes have difficulties with activities that require visual motor and visual perceptual abilities. Now, some children may be unable to count objects in a series of pointing to each of them and saying, perhaps, for example, 1, 2, 3, 4, 5. And some students are unable to see objects in groups or in sets, an ability needed to identify the number of objects quite quickly. And then there are some students with poor mathematics abilities who have poor visual motor skills, or whose visual motor skills are underdeveloped because their disorder in perceiving shape, recognizing spatial relationships, and making spatial judgment has not developed. And so they are unable to cope with geometrical forms and shapes and numbers and letters. Now, these learners are likely to perform poorly in handwriting as well as arithmetic. And those are all of the signs that might show up if it is that there is underdevelopment in terms of the visual motor and visual perceptual skills of a particular learner. And then we have the language and reading problems as well. Now, some learners with mathematic disability have superior verbal language skills and may even be excellent readers. However, the mathematics, however, some learners might be at the opposite side of that spectrum. The language disorder may cause perhaps confusion with mathematic terms such as plus or take away or minus or carrying over or borrowing and or place value. And so that really calls us to reflect on whether the strategy that some schools are currently employing to learners who are struggling in mathematics, and that is moving them from pure maths to maths lit, whether that strategy without proper assessment of a learner's language ability or language skills, does it really solve the problem, or does it just exacerbate the problem even more? And does it feed into the current negative connotations that learners are holding on to in regard to maths? And so we need to keep these things in mind. And then we have poor concept of direction and time. Now, basic concepts of time are typically acquired during the preschool years. And expressions such as 10 minutes ago, in a half an hour, and later are usually part of the preschooler's understanding and speaking vocabulary. Now, many students with mathematics disability have a poor sense of direction and time. And then we have memory problems as well. Now, students with severe memory deficits often understand the underlying number system, but they are unable to recall number facts quickly. Visual memory is also important for older students learning geometry, which demands that they remember different geometrical shapes and number of angles on figures. And if that skill is underdeveloped, it will affect how the learner engages with such a mathematical problem. And then we have lack of mathematics learning strategies. And then what I want to emphasize here is that some mathematics disabilities can be attributed to the learner's lack of appropriate strategies for attacking or solving math problems. And this basically also feeds into the third bullet point, which is language and reading problems, especially within the South African context. Now, learners need strategies for visualizing the problem, for knowing what is being asked, and for deciding on methods for solving the problem. Now, research shows that learners with learning difficulties often use no strategies or select an inappropriate strategy. And so if the instruction is not what it should be in terms of meeting the learner's need, that can contribute towards the learner not being able to solve the mathematical problem. And then we have maths anxiety. And that is why I asked the question in the beginning, who have a love of maths and who doesn't? Because the truth of the matter is that there are learners within our school context who love maths and they naturally gravitate towards that. And there are learners who have acquired the skill of maths, and there are those who perhaps have fallen through the gaps. But what we do know and what research has uncovered is that math anxiety, which is an emotional-based reaction to mathematics, causes individuals to freeze up. And many students and adults with learning disabilities report that anxiety is a constant companion. And if anxiety is a constant companion, what we need to keep in mind is that it then affects how the learner will function, because the limbic system in the brain is overactive, and the frontal lobe is not as active as it should be in terms of engaging with the mathematical problems. This brings me to the sequence of mathematics through grades. And as assessors, we need to have a general picture of the overall mathematics curriculum. It is important to know what the learner has already learned in the mathematics curriculum and what mathematics learning still perhaps lies ahead. And so mathematics should not just be thought of in terms of the grade in which the learner is, because mathematics is a naturally cumulative subject, typically taught in a sequence that introduces certain skills at each grade. For example, over here, if a learner is in kindergarten, right, there are basic number meanings, counting, classifications, recognition of numerals as writing, as well as writing of numbers, which is expected to be mastered at this particular level. And then we have grade 1, where you are expected to develop the skills of addition through perhaps 20s. And that then builds on to grade 12, up to grade 8, where it starts becoming scientific in the approach, by where graphs are being introduced or complex fractions are being introduced. But what we need to keep in mind is that there is a sequence that takes place, that is introduced from grade to grade. However, mathematics needs to be looked at as an accumulative subject. That therefore brings me to our conversation about assessment, assessing mathematics. Now, information about a learner's ability, as well as a learner's proficiency in mathematics, can be gathered through both informal as well as informal measures. Now, the informal methods include informal inventories, curriculum-based assessment, and analysis of the learner's errors, whereas formal instruments include standardized survey tests and individual clinical tests. In regards to informal measures, many researchers believe informal measures are the best way to obtain information about a learner's performance and ability in mathematics. Through informal measures, it has been uncovered that assessors or teachers can consider such questions as: what previous knowledge did the student bring to this problem? To what extent are the ideas accurate and complex? What strategy did the learner employ to solve the problem? And what is the child ready to learn right now? Hence, I emphasized that mathematics is a naturally accumulative subject, and it should be approached as such. What I also want to emphasize is that observations of a learner's daily behavior in mathematics and performance on homework, assignments, as well as on teacher-made tests or tests that accompany the textbook, can provide information for basic assessment decisions. In regards to the informal measures that can be employed, we have the informal inventory. Now, as a statist, you can easily construct informal tests to assess the learner's achievement in a specific math skill or a sequence of math skills. The informal test can be tailored to an individual student. Construction of informal test can consist out of 5 steps, and that is selecting a skill or a span of skills to be tested. And that can include arithmetic skills such as additions, subtractions, multiplication, as well as division. And then we have the following step, and that is assembling sample test items. For testing a single skill, it is recommended that you use at least 10 items for that skill. In other words, if you'd like to test the learner's skills in regards to how they engage with additions, and you would have 10 sums that falls under the category of additions as part of the informal inventory. And then number 3, have learners take the informal test. You may use timed or untimed condition. It is, it's always advisable to perhaps make use of both, just to see whether the learner will perform differently in the absence of time versus the presence of time, because we all know that time brings about some type of anxiety. And then number 4, score the tests and analyzing the students' test responses, and therefore determining whether the learner knows the skill or whether the learner has the necessary prerequisite mathematics skills and what type of errors the learner makes. And that will also inform the individual educational plan that is carefully being put aside as the assessment process unfolds. And then lastly, to determine the criteria that will be used to judge whether the learner knows the skills. And when the test is perhaps re-administered, the same test, but it needs to be done over time. And that basically targets what we have spoken about the memory problems that comes with mathematics skills. And then we also have the curriculum-based assessment, which is part of the informal measures. Now, the procedure of curriculum-based assessment provides a useful way to measure mathematics learning and progress. And curriculum-based assessment closely links assessment to the material that is being taught in the mathematics curriculum. The relation to mathematics curriculum-based assessment consists of these 4 bullet points. And the first one is to identify the target skill. Now, the skill might be math, computation, or adding 2-digit numbers, depending on the need of the learner. And then the second bullet point is to determine the objectives to be met. For example, in a period of 4 weeks, the learner will be able to write correctly the answer to 22-digit addition problems in 5 minutes. But that means that there's supposed to then be a track record that will help you triangulate that information. And then the third bullet point is to develop test items to sample each skill. This is done by assembling a collection of 2-digit number problems as well. And then lastly, to develop a criteria to measure the achievement. For example, learners will write answers without errors to 20 randomly selected 2-digit math problems in 5-minute period. And so it's all about also having these targets in place as well as the criteria that would give definition to why you are employing such an assessment. And then we have analyzing mathematics errors. Now, assessors should be able to detect the types of errors a learner with a mathematics disability is making so that instruction can be directed towards correcting those errors. Remember what I said previously in regards to the importance of instructions. This information is obtained by examining the learner's work or asking learners to explain how they went about solving the problems. And the 4 types of mistakes listed below are among the most common errors of calculation, and that is place value. Now, place value is the aspect of the number system that assigns specific significance to the position or digit holds in a number. Learners who make this error do not understand the concept of place, value, regrouping, carrying over, or borrowing. And then we have computation facts as well. And learners who make errors in basic in computation facts are learners who make errors in basic adding, subtracting, or multiplying and dividing and they need more practice and more drilling in terms of mastering that skill. And then we have using the wrong process. Some learners make errors because they use the wrong mathematical processes. And so it is important to help them break down the steps that comes with solving certain mathematical problems. And then we have working from right to left. Now, some learners reverse the direction of calculation and work from left to right. And in addition, poor writing skill will also cause many math errors, which we need to take note of. So when learners cannot read their own writing or fail to align their numbers in columns, they may not understand what to do. This brings me to formal measures. In terms of formal mathematic tests, these include standardized survey tests and individual clinical tests. It is important to check the validity as well as the reliability and standardization procedures of tests before using them, especially within the South African context. In terms of the formal measures, we have the standardized survey tests, and the standardized survey test provides information on the general level of a learner's mathematics performance. They are designed for groups, but they also can be given to individuals. Usually data are available on the test, reliability, validity, as well as the standardization procedure. Often there are accompanying manuals with tables for various kinds of score interpretations, including grade scores, age scores, or standard scores, and percentiles. Most of the survey tests in mathematics are part of a general achievement test battery. And one example of such is the group mathematics test. And this have been normed for children ages 6 to 8 years without challenges. and it can be used qualitatively and triangulation, and can be triangulated with other assessment tools. And then this takes about 20 to 25 minutes to administer. It is administered orally. Computations are present, as it can be administered to a group, or it can be administered to an individual. And then we have the 3 maths as well, which is appropriate to the South African context. And it is for learners from grade 4 to grade 7. Now, the 3 maths can be administered by psychologists as well as teachers, registered counselors, and psychometrists to help plan and implement intervention during early school years. It comes in 3 languages. There is Tswana, English, and Afrikaans, and it consists out of 3 parts. That is the study orientation questionnaire in mathematics, as well as the mathematics vocabulary assessment, and then the last sub-test in there is the basic mathematics. This is just an example of what comes with the test, and I've spoken about this in terms of the various kinds of score interpretation, as well as the grade score and the age score, the standardized score, and the percentile. So one would then use this table in order to work out the level in which the child is. Oops, what did I do? There we go. And then we have the individual clinical tests, which is designed for individual assessment. They often yield more of a diagnostic approach and give diagnostic information in comparison to the survey tests. It provides information on specific areas of mathematics difficulty, and more clues for planning in structure. And I've just included a picture of the WIAD over there. And in the WIAD, which is mostly used by psychologists or psychometrists, there are these sub-tests that is found in there, and those are the maths problem solving, the numeracy sub-test, the maths fluency addition, the maths fluency subtraction, as well as the maths fluency multiplication. And those are all of the subtests that makes part and parcel of the WIAD, and which is triangulated with other subtests as well. What we need to keep in mind when all is said and done, that the assessment is not done without an objective. Obviously, the results of the assessment will determine the way forward that needs to be taken. Therefore, I want to conscientize you about what is out there in terms of the support that is made available by the educational structures, and that is that there is concessions that can be applied for learners who have barriers in mathematics. And according to the document, there are obviously criteria that informs who will qualify for such concessions. Therefore, I want you to keep in mind that the assessment is not done in vain. It is always done with an end objective in mind, and therefore, as skilled helpers, when assessing, exploring, and understanding the data, that comes with having to take action and having to collaborate with other stakeholders. So the principles of instruction for learners with mathematic disability should always be kept in mind. And that is trust and relationship building. Because some children who might have struggled with maths, the trust and the relationship which underpins the approach to help might become a vehicle to the learner to perhaps open up to the possibility of conditioning him or herself with the maths content, which can bring about developing new neural parts within the brain, especially if interventions are early, and then facilitate learners' understanding of the situation or the narrative. And that goes back to the point that I've made in terms of language and reading problems, making sure that it is not a language difficulty that is impeding on the child's ability to perform certain tasks in regards to maths. It is important that we establish that, because there's just too much research that shows that not proper interventions are made when children are switched from maths, pure maths, to maths lit. And that the struggle actually continues. So it is important that we keep that in mind. And then addressing options for a way forward. It is important to, when assessing learners, to not just lean on the data that is provided, but making time in order to engage with a child orally, so that it gives the child an opportunity to explain how they got to a certain solution, so that as an assessor, it informs you perhaps what needs to be put in place instructional wise that will support and help the learner overcome the way of thinking in terms of their quantitative application. And then agree on the action to be taken, that is with the learner, as well as with the learner's parents, as well as all of the other stakeholders which are involved. And then reach out to the stakeholders and professionals as agreed on above. That is very important. It takes a village to raise a child. And so we need to apply that philosophy in the way we do assessment as well. So know when to refer for concession. And please do keep the following points in mind when applying for concession. And that is that learners from grade 1 to 9 who has mathematics not used as promotional requirements, that learners with dyscalculia are granted a concession, exempted them from offering mathematics or mathematical literacy from grade 10 to 12, but assessment directory mathematics is replaced by another subject, and a psychological report, previous school report, and sample work of the learner are required. What does that mean? It means that when we do have a conversation about the report in itself, which is our next session, we will establish what the purpose is of your report, and the recommendations that comes with it, which the document will be part and parcel of forwarding to for intervention or further assessment. if it is that a psychological report is needed, and if it is, that concessions will be applied for. Okay, and that brings me to the end of my lecture this morning. Let me just quickly check in the chat box if there are any chats. Okay, I see Sue saying the report is due in 2 weeks. Covering the needs in 2 weeks is a bit late. Thank you to Courtney. Yes, she did speak to me, and she did say to me that you guys will be having a session in regards to the report writing as per the students' requests. It sounds as if that session already happened. Am I correct, Sue? Oh, it's this week. All right. Thursday. Okay. Thank you for sharing that. Courtney and I are in conversation, and we have spoken about the report and her giving a session on that this week. And so she will be guiding you through that process. What I do want to encourage each and everyone is to take all of the information that you have gathered, because that is where all of it will be triangulated and consolidated. So please make sure that you are available for the tutor session that is scheduled for Thursday, because Courtney will be having an in-depth conversation about your report. Thank you so much. If there are no other questions, not a problem. It's a pleasure, Briggs. If there are no other questions, thank you for being here, everybody. I'm looking forward to engaging with your reports. And please do reach out if there are any difficulties and you need support. As soon as the report, as soon as the report has been submitted, that brings about relief, doesn't it? And it's just a matter of then giving feedback.
Mr. Deon?
Good afternoon, sir. Sandile, how are you?
Yes, yeah, we did attend the tutorial on Thursday night.
Oh, was it already? Did it already happen?
Okay. Yes, it already happened.
Okay, so I will also load the tutorial up onto Moodle as soon as I've received it from Courtney.
Okay, no problem. Yeah, it was fruitful.
Thank you so much, sir. Thank you. It is 9:45. We are finishing 10 minutes before our session is supposed to end. Can we use the 10 minutes just as a stretching break before continuing with the other session, which will be taking place at 10 o'clock? Thumbs up. Thank you, everyone.